Mr. Clown here from Clown Math. This is the SQA Higher Maths 2024 Paper 2 that you probably sat today if you're watching it right now. Let's get started straight away, shall we? SQA Higher Maths 2024 Paper 2 Question 1. Triangle ABC has vertices A, B and C with the numbers on them as you can see. You have to find the equation of a median through B. So first glance at this question is, it looks a little bit complicated the way it's drawn, but it's probably going to be okay if we just keep our heads on. So median through B means the line that goes from B and it cuts the opposite line in half. So it's cutting that in half, so I need the midpoint. Let's just call that M, a midpoint of A and C. So I need the mid of AC. So that's minus 3 plus 11 over 2. And it's 8 plus 0 over 2. So let's just work on that. Remember, use a calculator anytime you want. I might not use a calculator much in this paper, but it just depends. So we've got minus 3 plus 11. What does that give me? 11, 10, 9, 8. 8 over 2. And we've got 8 plus 0 over 2. That's 8 over 2. So that's a nice one. That's 4, 4. So there's my midpoint. And now I need my gradient. So I need my gradient between B and M. So gradient between B and M, I've just called it. So B is minus 1, minus 6. So I'll just say 4 minus minus 6 over 4 again, minus minus 1. That gives me 10 over 5, and that's a 2. So my gradient is 2, so y minus b is mx minus a, y minus 4, 2x minus 4, y minus 4 equals 2x minus 8. So y equals 2x minus 8, add 4 is minus 4, and we're done there for part A. Part B says, find the equation L, the line perpendicular to BC passing through C. So there is C there. So there we need the gradient of BC, because we're going to use M1, M2 minus 1, and then we'll just use the point C. So for part B, we need the gradient of B and C. So let's just check our points. We've got 0 minus minus 6. And we have 11 minus minus 1. So that is just 6 over 12, which is a half, and therefore the gradient of the perpendicular is minus 2 because M1, M2 equals minus 1. Always need that little statement. And now we use the point C. C is 11, 0. So we're going to use C, which is 11, 0. So Y minus B, that's 0, equals M, X minus 11. So that just gives me y equals minus 2x. A minus times a minus is a plus, plus 22, and we're done there. Part C, determine the coordinates of the point of intersection between the median and the line. So we've got two equations, 2x minus 4 and minus 2x plus 22. So for part C, y equals 2x minus 4. And we've also got y equals minus 2x plus 22. So we can just say that 2x minus 4 is minus 2x plus 22. Taking the 2x over to this side gives me 4x. And taking the minus 4 over to the other side, add 4. 22 plus 4 is 26. X is 26 over 4, which I'll just simplify to 13 over 2. I'll just leave it as a fraction, why not? When x is 13 over 2, I need to find the y. So y equals 2 times 13 over 2, 2x minus 4. So that's 2 divided by 2 is 1, so that's just 13 minus 4 then. 13 minus 4 is 9, so the point of intersection we can say is equal to 13 over 2 for the x and 9 for the y. And we're done there for question 1. SQA Higher Maths 2024 Paper 2 Question 2. A curve has equation y equals 8 over x cubed, x is greater than 0. Find the equation of the tangent at x equals 2. So equation of the tangent means differentiation to find the gradient, and then sub x into y to find the point, and then use straight line stuff as normal. So let's just differentiate this. We've got y equals 8x to the minus 3. So the y by dx is minus 3 times 8 is minus 24x. Take 1 away for the power is minus 24 over x to the 4, and since because I don't like using a calculator that much, I'll just put that as x to the 4 in the bottom. So at x equals 2, the gradient is equal to minus 24 over 2 to the power of 4. Well, 2 2s are 4 times 2 is 8 times 2 is 16, so that's minus 24 over 16. And 8 goes into both of them. 8 3s are 24, and 8 2s are 16, so minus 3 over 2. But again, use a calculator anytime you want. So now we need a point. So when x equals 2, y equals 8 over 2 cubed. Well, that's quite nice because that's 8 over 8, which is 1. So our point is 2, 1, and we've got our gradient. So now it's just y minus b equals m x minus a. I'll just take the 2 up, and a lot of people would do that, I think. So expanding, 2y minus 2 minus 3x plus 6, watch for your minus minus. And I'll just take everything over to the left, 2y plus 3x minus 2 minus 6 is minus 8, and that equals 0. Or you can leave it in any other form you want, 2y plus 3x equals 8. Or you can even divide 3 by 2, but I don't know why you would. And that's us done for this question. SQA Higher Maths, 2024, Paper 2, Question 3. The coordinates D, E and F are given by these 3D coordinates. Express E to D and E to F in component form, and then calculate E to D dot E to F and find the angle. Oh, that's nice. We're doing it in bits, are we? So let's do E to D. So remember, that's just D minus E. So D is 2 minus 3 and 4. And E is 1, 1 minus 2. Taking them away and being careful not to mess it up. 2 minus 1 is 1. Minus 3 minus 1 is minus 4. And 4 minus minus 2 is 6. So there is E to D. Same for E to F. F minus E, that is. So we've got 3, 2, 1. Minus 1, 1 minus 2. 3 minus 1, that's 2. 2 minus 1 is 1. 1 minus minus 2 is 3. So that's us done part A. Part B, part 1. ED dot EF. So we've got to do ED dot EF. So ED is 1 minus 4, 6. I have to dot that with 2, 1 and 3. So that's 1 times 2 plus minus 4 times 1. Don't know why I'm writing a plus sign here. Plus 6 times 3. 1 times 2 is 2. Minus 4 times 1 is minus 4. 6 3s is 18. 2 minus 4 is minus 2. Minus 2 add 18 is 16. So we get 16. Hence, always calculate the size of angle DEF. Well, let's just check it. We're not trying to trick us here. We've got E to D, E to F, say. So, yep, I think that's okay. So we're just doing the angle in between. So from the start of the exam paper, if you just look, you get A dot B equals size of A, size of B, cos theta. So just slightly rearranging that, cos theta is A dot B over size A, size B. So for this example, cos theta is, we've got ED dot EF, ED dot EF, all over the size of ED and the size of EF. So that is just 16 over something. So I need the size of ED. So let's look at ED again. ED is equal to 1 minus 4 and 6. So the size of that is just Pythagoras, square root 1 squared plus minus 4 squared plus 6 squared. That is 6 6 is a 36, 4 4s is 16, 36 and 16 is 46, 52, plus 1 is 53. So you get root 53 for that one. And then EF, remember, we had 213. So the size of EF is just equal to the square root of 2 squared plus 1 squared plus 3 squared. 2 2s is 4, 3 3s is 9, 4 and 9 is 13, and 1 is 14, I think. So we get root 14. So that means that our cos theta is equal to 16 over root 53 root 14. So now it's a calculator job to get theta. Theta is the inverse cos of all of that nonsense. 16 over root 53 root 14 shift cos 16 divided by open bracket root 53 times root 14. I get 54.028. Or if you want to round it, degree sign anyway, 54 degrees would be perfectly acceptable, I think there. 52.03, 52. Who cares almost? And there we are, we're done there. SQA Higher Maths 2024, paper 2, question 4. The diagram shows the graph of a quartic function. Wow. The maximum turning point occurs at -1, 3. The graph of y equals f of x has a point of inflection at x equals 2. And always a turning point that doesn't turn, keeps going down. And determine the coordinates of the maximum turning point of the graph of y equals f of x minus 4 plus 2. Well, the turning point to start with is -1, 3. So we're starting with -1, 3. Now this bit here, the bit that says x minus 4 means a shift to the right by 4. So I'm going to go right by 4. And then the bit at the end, plus 2, up by 2. So that becomes -1 shifts to the right, -1 add 4, that gives me 3. 3 goes up by 2, that gives me 5. 3, 5, job done. Part B. In the diagram in your answer book, sketch a graph of the derivative y equals f dash x. So I've got a method for this, and this is my method that I use. I do this as if I'm doing a nature table basically, and I'm going to say that's my derivative. And I'm going along to the turning points, because the turning points on the graph of the derivative turn into roots, because the 0 gradient. So the first turning point is -1. And then we go along and we get another turning point at 2. And then we go along. And then we just examine what happens before and after this turning point. So checking my graph. I'm going up the way, so that's positive. Then I'm going down, that's negative. And then I'm going down again, that's negative. So it's positive, negative, negative. So I can just write that. So the first one is positive, that's 0, negative, that's 0, and negative. So in terms of thinking about where I'm drawing this, I'm drawing that above the x-axis, on it, below it, on again, and then below. So then what you do is you get your diagram. Now I've not got one because I've not got an answer book yet, because I'm not a student. So I'll just draw it by hand. X and Y. You put your turning points on as your roots, -1. Let's just call that 2. And I'm thinking I'm above before -1, so I'll just put a wee mark, just to remind me. And then I'm below after -1. And then I stay below. And then I need to go back up here and then go down a low. So that must be a turning point that I just touch and hug. So we can just kind of think of this as we're going to go down. We need to go up at some point, and then we're going to go back down. So that looks like a decent graph, and we're done there. SQA Higher Maths 2024, paper 2, question 5. Evaluate the integral between 0 and pi/7 of sine 5x dx. A simple one, this. Start of exam paper tells you if you integrate sine ax, you get -1/a cos ax. So that's what I'm going to get. -1/5, because that's my a, cos 5x, plus, well, not plus c because I'm putting numbers in. And that's the chain rule. What has happened here is you've the derivative of 5x, which is 5, and divided by it, and sine goes to minus cos. So now I just sub my numbers in as per usual. -1/5 cos 5 pi/7. That's one of them. Take away -1/5 cos 5 times nothing. I'll just put nothing in. Now, not expected to know these. Calculate a job. Make sure I'm in radians. So let's just check it's -1/5 at the front, right? So -1/5, 1 divided by 5 is 0.2, so I'm just going to do that. -0.2 times cos bracket 5 pi/7 is 0.1247, say. And minus, well, cos is 0, you should know is 1, but I mean, we'll put a calculator here, so let's just check 1. So -1/5 times 1 is -1/5, so we've got a -1/5. Well, a fifth is 0.2, I've already established that. So it's 0.1247 plus a fifth, which is 0.3247. Or, if you wanted to round it, but 0.325, I suppose, would be fine. And there's no degree sign or nothing like that, we're in radians anyway. So we're done there. SQA Higher Maths 2024, paper 2, question 6. Two variables x and y are connected by the equation y equals ax b. The graph of log 5y and log 5x are shown and it's a straight line. So we've got log 5y by log 5x and find a and b. Right, so I always usually start with the equation. Some people skip ahead, but I don't like to. So I'll start with that and I log both sides. The base is 5. Log base 5 y equals log base 5 ax to the b. So now I can separate my log out on the right hand side to log base 5a plus log base 5 x to the b. So that means log base 5y equals log base 5a plus b comes out the front, log base 5x. And put that in a kind of form of y equals mx plus c. You've got your log base 5y. I'll take the x bit first. So b times log base 5x plus log base 5a. So now just comparing your graph, your y-axis is log base 5y, so that's like your y, and your x-axis is log base 5x, so that's like your x. So that bit there is your gradient, mx, and that bit there is your c. So the gradient is b. So what's the gradient of this line? Well, I've got 2 points, 0, -2, and 410. So the gradient between 0, -2 and 410 is what we're going to do. So my gradient equals 10 minus -2, 4 minus 0, that's 12 over 4, that's 3. So that means that, to answer the question, b equals 3. Now it says find c. Well, I already know where it cuts the y-axis, 0, -2. So that's it, c is -2. So if c is -2, that means that log 5a equals -2. So that means that 5 to the power of -2 equals a. That's 1 over 5 squared. 5 squared is 25, so a is 1/25. And we've got that, so we're done. SQA Higher Maths 2024, paper 2, question 7. The diagram shows the curve of equation y equals x cubed minus 6x squared plus 11x, intersecting the curve of equation y equals 6 plus 4x minus 2x squared at x equals 2, which is here. Now, I have to elaborate shading this in before I filmed this because there was no way that with a scan you could tell what bit you were actually meant to be finding. So it is that purple bit that I've shaded in for you. So we've got two curves. We've got an upper and a lower. So let's identify the curves. This one is above and this one is below. So it's upper minus lower. So it's the integral between 0 and 2, because that's an area. The upper curve is 6 plus 4x minus 2x squared. And we have to take away x cubed minus 6x squared plus 11x dx. So we need to work some of that out. Integral between 0 and 2 then. I've got 6, 4x minus 11x. So 4 minus 11, 4, 5, 6, 7, 8, 9, 10, 11, 6, 7, minus 7x. I've got minus 2x squared minus, so that's plus 6x squared. 6x squared minus 2x squared is 4x squared. And then I've got minus x cubed. Now you can rewrite that in a different order if you want, but I don't see the point, so just leave it like that. Now we just integrate 6x minus 7x squared over 2 plus 4x cubed over 3 minus x to the 4 over 4, and we sub in 0 and 2. Okay, so always write your substitution because you get marks at this point. So there's my first bit subbed in, we are 2, and then take away 0. Now it is all 0, but I'll write it anyway for the sake of the video. But you should be able to see that we're all x's and zeros, so it's just all that 0. So now be very careful doing it in stages if you have to. So I'm just going to do 6 times 2 is 12. 2 2s is 4, divided by 2 is 2. 2 7s is 14. Now use a calculator anytime you want, but I usually do each term individually. 2 cubed is 8, 8 fours is 32, so that's 32 over 3, which I'll just leave as a fraction for now. 2 twos is 4 times 2 is 8 times 2 is 16, and 16 divided by 4 is 4. So that's my bracket. Take away 0, 0, 0, 0, 0. So we have got 12 minus 14. 12 minus 14 is minus 2. Minus 2 minus 4 is minus 6. So we've got minus 6 plus 32 over 3. And because I can't actually bother get my calculator out, I'll just work that out for you. 6 threes is 18. So that's minus 18 over 3 plus 32 over 3. Now 32 minus 18 is 22, 12, 14. So you get 14 over 3. That is an actual simplified fraction. It's an area, so it's got units and it's squared. And we're done there. SQA High Maths 2024 Paper 2 Question 8. Functions f and g are defined on R of a set of real numbers by 2x squared minus 18 for f of x. G of x is x plus 1. Find an expression for f of g of x. F of g of x, you usually get a mark for substitution. So it's 2 g of x squared minus 18, just to show that. G of x is x plus 1. So you just go straight to this step if you want, minus 18. Now I think you'll get all the marks for that. You don't need to do anything else. And the way I've solved this, it's handy to have it like that. But in case anyone did multiply it out, I'll multiply it out. 2x squared plus 2x plus 1 minus 18. So that gives me 2x squared. 2 2s is 4x. 2 1s is 2, but 2 minus 18 is minus 16. So either of them should be fine. Question B says, find the values of x so that 1 over f of g of x is undefined. Well, that means that you can't have that bottom bit being 0. So that means that you could say that f of g of x cannot equal 0. So I want to find the numbers which make that happen. So I'll just make it equal to 0 and see what I get. So you've got 2x squared plus 4x minus 16 equals 0. But notice at the start, that was in completed square form. So you can start from that point and probably solve it a lot quicker. Or you can start from this point. Since I'm here now, I'll just do that anyway. So I've got 2 bracket x squared plus 2x, and I've got minus 8 equals 0. So that's 2 double brackets. Let's hope it actually factorises in if we're doing it this way, because I would do it another way. I think it's going to be 4 and 2, is it? Okay. And I want plus 4 minus 2. Okay. So I've got x equals 2, x equals minus 4. So you just say undefined when x equals 2 or x equals minus 4. Find the values of x, so it's undefined. Undefined when. You could actually answer the question by saying that if you wanted to say what the range is, you could say that x is a member of R and x cannot equal minus 4 and x cannot equal 2. But really, we're saying what values for x is this undefined. So if it's undefined when x is equal to 2 and x equals minus 4 is actually the answer. Now, going back up, if you'd done it from completely square form, just as a kind of side note this, 2x plus 1 squared minus 18. This is the power of completing a square. That means that I can take the 18 over 2x plus 1 squared equals 18. And that means that x plus 1 squared equals 18 over 2 is 9. I can just square root both sides. That gives me x plus 1 equals plus or minus 3. So x equals, when it's plus 3, 3 minus 1 is 2. And when it's minus 3 minus 1 is minus 4. And you would get the same thing. And there we are. Determine the coordinates of the stationary points in the curve with equation a third x cubed minus x squared minus 3x plus 1, then the greatest and least values between that interval. Well, let's do part A first. Stationary points occur, you need to write this, when dy by dx equals 0. So what's dy by dx? 3 times a third is 1, so it's just x squared minus 2x minus 3, and we're going to say that equals 0. So we should be able to solve that. Let's hope it factorises. X and x, 3 and 1. And we've got minus 3 plus 1 is minus 2. So there we go. So x is minus 1 or x equals 3. Now read the question, determine the coordinates. So when x equals minus 1, y equals 1/3 minus 1 cubed minus minus 1 squared minus 3 times minus 1 plus 1. So minus 1 cubed is minus 1, so that's minus 1/3. Minus 1 squared is 1, times a minus is minus 1. Minus 3 times minus 1 is plus 3, and then I've got plus 1. So I've got 1 minus 1, 0. 3 minus 1/3 is 8/3. But you can use a calculator anytime you want. So the coordinate is minus 1 8/3. So that's our first coordinate. And our second coordinate, when x equals 3, y equals 1/3 times 3 cubed minus 3 squared minus 3 times 3, and then we've got plus 1. So 3 cubed divided by 3, 3 3s are 9, 3 is 27, divided by 3 is 9. 3 squared is also 9. 3 3s is 9, plus 1. 9 minus 9 is 0, minus 9 is minus 9, plus 1 is minus 8. The coordinate is 3 minus 8. And we've got both our coordinates. Notice it doesn't actually mention to find our nature, so there's no actual real need to do so. Part B. Determine the greatest and least values of y in the interval minus 1, x, and 6. Minus 1 is less than x is less than 6 in the equation. 1/3 x cubed minus x squared minus 3x plus 1. Now, with this is us testing limits here. Now, at the end, either the max and min occur at the end of these points, or they occur in the middle, in which case you occur at the turning point. Now, one of the turning points is already minus 1, so we've already checked minus 1 is 8/3. So when x equals minus 1, we can already say that y is 8/3. We've already got a 3 for our turning point. When x is 3, y is minus 8. So now we just need to check 6 to see if that one is bigger or smaller. So when x equals 6, y is 1/3 times 6 cubed minus 6 squared minus 3 6's plus 1. Hopefully you can kind of see if this is going to be a big number, because let's just get a calculator. 6 cubed, divide that by 3 is 72, minus 36, minus 18, plus 1. Now, since I've got a calculator out, I'm not going to be stupid, I'm going to actually use it. That is 19. So then we just say the answer. Now just answer a question. The greatest value is equal to the biggest of all the numbers. We've got 8/3 minus 8 and 19. 19, you could say at x equals 6. You don't need to. And the least value is the smallest number, which is minus 8. And that occurs at x equal 3. And we're done there. For paper 2, question 10, circle C1 has the equation x squared plus y squared plus 18x minus 2y minus 8 minus equals 0. Find the radius and centre. So start the exam paper for this. Usually for part A, I'll just do it here actually, you would say 2g equals the number in front of x, 18, and 2f equals the number in front of y minus 2. So g is 9. And f is minus 1, and from the start of the exam paper, the centre is minus g minus f, so that is equal to minus 9 and 1. Now we want our radius. So from the start of the exam paper, the radius is the square root of g squared plus f squared minus c. I usually remember it like this: the square root of the centre numbers added together, take away the last number. So minus 9 squared, and plus 1 squared, and minus 8, so plus 8. So that equals the square root of 9 9s are 81, 1 1s are 1, plus 8. 81 plus 1 is 82, plus 8 is 90. All surds should be simplified in higher maths. Root 9 root 10. That's 3 root 10. So there's our radius, and there's our centre. And we're done there. Part B says, the second circle C2 touches C1 internally. The centre of C2 is minus 6, 0. Determine the equation of C2. Well, there's our new centre for this big circle, minus 9, 1. Now, if you imagine taking the centre of this and the centre of that, if I did this big one minus that one, it leaves me what's in between, which is, well, the distance between the centres. So we can use that fact quite handily, that the radius of the big one minus the radius of the small one equals the distance between the centres. We're going to say that R2 minus R1 equals D, because they touch internally. So we already know R2, it's 3 root 10. We don't know R1, but do we know D? Well, we've got two coordinates. Distance formula, so D equals the square root. We've got minus 9 minus minus 6, or the difference between minus 9 and minus 6, and the difference between 1 and 0. The difference between minus 9 and minus 6, minus 9 plus 6 is minus 3, that's squared of course. Square root of minus 3 squared plus 1 squared, that's 9 plus 1 is 10, root 10, so that equals root 10. R1 over to this side, you get 3 root 10 minus a root 10, so R1 equals 2 root 10. So now we've got a radius and we've got its centre, so the equation from the start exam paper is x minus a squared plus y minus b squared equals r squared. X minus minus 6 plus 6 squared plus y minus 0, so plus y squared equals, careful, 2 root 10 all squared. So working that out, I get x plus 6 squared plus y squared equals 2 2s is 4, root 10 times root 10 is 10, so that's 40, and we're done there. SQA Higher Maths 2024, Paper 2, Question 11. The number of electric vehicles worldwide can be modelled by n equals 6.8 e to the kt, where n is the estimated number of vehicles in millions, watch out for that word. T is the number of years since the end of 2020, and K is a constant. Use the model to estimate the number of vehicles worldwide at the end of 2020. So at the end of 2020, T equals 0, so you get n equals 6.8 times e to the 0, which is 1. So that's 6.8, but it's not 6.8, it's 6.8 million. You'll probably lose a mark if you miss that word, because it's not 6.8. Part B. At the end of 2030 is estimated at 125 million electric vehicles worldwide, determine the value of K. So we want n is 125 million, 125 equals 6.8 e to the power of, and K, T. So T, 30, 20, 10 years, 10K. So that's a logarithmic equation. It's going to turn it, we're going to use logs because it's an exponential. So divide by 6.8. That equals e to the 10k. Take the natural log of both sides. ln, I'll write 1025 over 6.8 equals ln e to the 10k. 10k can come down to the front to get ln e, which is just 1, remember. And that is ln 125 over 6.8. And therefore, k is very simply ln 125 over 6.8, all divided by 10, which is a calculator job. ln 125 over 6.8, all divided by 10, 0.2911, blah, blah, blah. I think 291 is fine, 0.291, and that's K. Have we answered the question? Yes. So we're done there. SQA Higher Maths 2024, Paper 2, Question 12. Solve the equation, which is a trig equation, sine 2x, 2 sine 2x minus sine squared x equals 0. Let's expand that. So let's expand that. It's 2 times 2 sine x cos x minus sine squared x equals 0. So that's 4 sine x cos x minus sine squared x equals 0. That's a little bit tricky, that, because if you take sine x out as a common factor, you're going to get sine and cos in one of the brackets, and that's going to look really funky. So some of you might have been tempted to go sine squared plus cos squared equals 1, maybe not getting away with that, but there are other trig identities you could have used, and one of them is sine divided by cos is tan. So if I divide by cos, you're going to, in a minute, once I take a common factor out, you'll see what's going to happen. So that's the route I'm going to take. I'm going to take common factor out of not 4 of course, just sine x. And I get 4 cos x minus sine x equals 0. So I've got sine x equals 0, easy enough there. And 4 cos x minus sine x equals 0. So I'm going to divide the whole of this by cos x, because if I do that, divide both sides by the same thing, as that's allowed, I'll get rid of the cos x from the first term and I'll get a tan x in the second term. So there's not a bit of trick there. So I'm going to divide this side by cos x, and similarly this side by cos x to be fair. So cos x divided by cos x is 1, so that gives me 4. Sine divided by cos is tan, so that gives me tan x. 0 divided by cos x is 0, and therefore tan x equals 4. And now I can solve both my equations. Inverse sine is 0. Well, you should know that. We need a calculator for that, but let's just check. There's your graph there. And we're in radians or not? Nope. So you've got 0, 180, and 360. Now be very careful here. X for this is equal to, the limit is between 0 is less than or equal to x, so 0 counts, but then less than 360. So 360 doesn't count. So it's just 0 and 180 degrees for this one. 360 does not count, it's outside our range. Inverse tan of 4 then. Make sure you're in degrees. 75.96. .96, and then cast diagrams, what a lot of people usually use, so I'll just use that. We're positive, so I can do 180 plus 75.96, which gives me 255.96. So x equals 0 and 180, and x equals 75.96 and 255.96. Or you might prefer 76 and 256, and that would probably be fine as well. Okay, we're done there. SQA Higher Maths 2024, Paper 2, Question 13. The diagram shows the graph of y equals f of x, which is a quartic function. How interesting. So, express f of x in the form kx plus a squared x plus bx plus c. Okay, so how you go about this is, those are roots, and roots can turn into factors. So, when x equals minus 1, the factor, is x plus 1. Similarly, when x equals 3, our factor is x minus 3. But that's a turning point, and if a turning point is a root, that means that one's squared. And then when x equals 5, our factor is x minus 5. So we've straight away got f of x, and I'm going to write these in order. The order is written here, k, x plus a squared, x minus 3 squared, x plus b. So the next one I come to is minus 5n plus 1, or plus 1 and minus 5. It really doesn't matter, does it? What we got? Nah, it doesn't really matter at all. So I'll just put them in the order, x plus 1 and x minus 5. The order of it there here is roots, minus 1 and 5. So we've still got a k in the way. But we've got a point, 0 minus 9. So you just sub that in. When x equals 0, y, which is f of x, is minus 9. So that means we've got minus 9 equals k, minus 3 squared, 0 minus 3, 1, and minus 5. 0 plus 1 and 0 minus 5. So minus 9 equals k times 9 times 1 times minus 5. So minus 9 equals 9 5s is 45, minus 45k. So k is minus 9 over minus 45. 9 is a common factor, so that's 1. 9 5s is 45, that's a fifth. Finally, answer the question. F of x is equal to 1/5 of x minus 3 whole squared, x plus 1, and x minus 5. And we're done there. This has been Clever Maths. Today we went through the whole of SQA Higher Maths 2024 Paper 2. Hopefully you did. If you do, like and subscribe, give it a thumbs up, and come back soon. Next video to watch is on the screen right now.